In this video, we're going to look at 3 rules in the manipulation of logarithms that will help us as we try to study these equations. The first is that log base lowercase a of a times b equals log base a of a plus log base a of b. So first we're going to make some definitions here, some assignments. We're going to call the log base a of a, we're going to simply call that x. And we're going to call the log base a of b, we're going to call that y. Now, when we look at these, we understand that what log base a of a equals x is saying is that a to the x equals a. And what log base a of b equals y is saying is that a to the y equals b. Now, then, if we say, let's go back to our original. If we say log base a of a times b, let's make those substitutions, equals log base a of a to the x times a to the y. But from the rules that we already know about exponents, we know that that equals log base a of a to the x plus y. Now we have to think about, what does the statement log base a of a to the x plus y mean? It's saying, what is the number to which you have to raise a to get a to the x plus y? And that simply is x plus y. But x plus y is log base a of a, from our definition of x up here, and plus log base a of b, from my definition of y up here. So now we have proven that log base a of ab equals log base a of a plus log base a of b, which is the first of the rules of logarithms that we're investigating. Now we're going to move on to the second law of logarithms. Log base a of a over b equals log base a of a minus log base a of b. And we're going to start this by simply rewriting log base a of a equals log base a of a over b times b. That's fairly simple. Now we're going to use our what we had up here, our first law, to say log base a of a equals log base a of a over b plus log base a of b. Now we'll move this over to this side and rewrite this simply as log base a of a over b equals log base a of a minus log base a of b. Our third and final law involves raising a to an exponent. We'll call that exponent c, and we're saying that log base a of a to the c equals c log base a of a. This is the third law of logarithms. So here's our proof of that. We're going to assign the value log base a of a to the variable x. So that means what? That means that x is the value, the power to which you have to raise lowercase a to get uppercase A. In other words, a to the x equals a. Now, we can go back and ask ourselves now then, what is the log base a of a to the c? We're going to substitute a to the x for uppercase A. So that is log base a of a to the x to the c. But we know that that is log base a of a to the xc. And what is log base a of a to the xc? It is what is the number to which you have to raise the base a to get the number x to the ac? Well, that's simply obviously xc. But x equaled log base a, so xc is going to be equal to c times log base a of a, which proves our relationship log base a of a to the c equals c times log base a of a. Now that we've proven these three relations, let's test them out using our TI Inspire CAS calculator app. So we're going to create a document and we're going to add a calculator to it. And first, let's test the first one, the multiplication relationship. So we're going to say log, and we're just going to put in numbers here, log base 3 of 5 times 7. And we're going to ask what that equals, and we're going to ask for it in an approximation answer, 3.23622. And now we'll test out the relation. We'll say log base 3 of 5 plus log base 3 of 7. And again, we're going to ask for the answer in an approximation, and we'll see that it's the same. Now, let's look at log base 3 of 7 divided by 5. Again, an approximation, 0.30627. Now, let's look at log base 3 of 7 minus log base 3 of 5. Again, an approximation answer, the same, 0.30627. Now let's look at log base 3 of 7 to the 5th power. Approximation answer, 8.85622. And now let's look at 5 times log base 3 of 7. And the same answer. So that is an example of the use of the laws of logarithms and showing their correctness, at least in these numerical examples. Thank you. I hope you've enjoyed this video. I look forward to seeing you again soon.